Thank you, Juan. I really like your house. I think I will stay over for the weekend. So, we've just heard from Paco and Sarah how digital twin and hybrid digital twin can tackle environmental issues. But now, we'd like to come to our own infrastructure company, Colas, within the Bouygues Group, and see how you are pioneering digital twin platforms for infrastructure resilience. So I'm joined by Maud GUIZOL, who's BIM and Digital Construction Director at Colas Group. Maud leads not less than 3 teams. How do you do that, Maud? Operational excellence, BIM, and the development of Twin, a digital twin platform of which we will hear about in a few minutes, and to help cities and regions adapt to environmental risks and improve infrastructure performance. So first and foremost, let's talk about a new notion, territorial digital twin. What are we talking about exactly?
So a territorial digital twin is a dynamic digital double of a territory that aggregates different data. Which data? Data from BIM, Building Information Modeling, from GIS, Geographic Information System, data from sensors, and of course, open data. And this digital twin enables us to visualize, anticipate, simulate, and monitor the operation and the transformation of cities and territories. And this in support of public decision-making, ecological transition, and operational efficiency.
Well, let's come now to Twin. I like the pun, by the way. It's a great name. Talk to us about it. Is it just another BIM tool, or is it something more transformative?
No, it's not just a BIM tool. Twin is the Colas Territorial Digital Twin. Concretely, it's a cartographic platform of our activities and territories. Think of it as Google Maps, but dedicated to construction.
And how did you originally get the idea? How did Twin initially come to mind in such a traditional industry as Colas?
Yes, the idea of Twin was born in 2017, and at that time we would like to create a territorial digital twin by bringing together BIM and GIS. Why? We were convinced by the fact that this convergence was key. Indeed, at the project level, it's very important to integrate your BIM model in the real environment and cross it with GIS information. And at the territorial level, you can aggregate different BIM models to have a global vision of your territory and better manage your territory. So Twin is not just a BIM tool, it's a very simple and user-friendly platform to have access to augmented data, integrated services, and a multi-scale visualization.
Well, that's fantastic. So it's all about connecting your projects, your infrastructure projects to the territory you belong in. So can you share now how it is used Twin at Colas? Who is using it and for what concrete applications?
So today, more than 3,000 employees use Twin across 32 countries and over different business lines, from design offices and project managers to labs, equipment, R&D. So how they use Twin? They use Twin to contextualize their projects, to de-risk studies, to optimize resources, and to monitor the performance and the sustainability of infrastructure. To give you an example, to respond to a tender, they will integrate clients' data, look for open data around the projects, such as biodiversity or soil report, and even they can optimize truck route calculation.
So maybe tomorrow we'll be able to introduce Sarah's models into your problem. But can you tell us a bit more what problems, because we've seen that we need to go with problems first, not solutions. I remember Niels again. Huh? So what problems does it solve? Can you give a few examples? And is AI playing a key role, the topic of the day in TUIN?
Yes, let's take the example of predictive road maintenance. At Colab, we developed InfraCare. It's a solution based on artificial intelligence to detect road damage. So we integrate this information into TWIN. We cross it with the nature of asphalt. So how we have this information, we cross the GPS data of our vehicles with the delivery note. So on TWIN, we have the road damage, the nature of asphalt, and we know the weather at that time the asphalt was laid. So by cross-analysis, we can better predict our maintenance. And this is exactly the strength of TWIN, combining different data to address new use cases.
Well, fantastic. This is really promising. So beyond predictive maintenance, have you used TWIN to address unexpected challenges? So many of them are happening in a recent infrastructure project?
Yes, we use, for example, the data for bike lanes. So the idea is to take open data, to integrate it into TWIN, and to identify if the bike lane is usable or not. And after, we can better communicate with the local authorities and to propose some solution.
Well, let's come back to TWIN, and can you open the hood for us a little bit more? And we've seen that there were very precise and accurate questions. So can you tell us a bit more about how it works?
Yes. TWIN is based on three main pillars. The first one is a technology of convergence between of BIM and GIS, with a very seamless visualization from a project to a district to a city and even to a territory. And thanks to TWIN's technology, you can open more than 80 different types of format: PDF, BIM, CAD, and this without specified licenses. The second pillar of TWIN is data. So we have three different sources of data. Data from our past projects. We have already stored more than 50,000 documents on TWIN. We have data, for example, reports of photos or point clouds or BIM models. The second source of data is data from our business applications, such as construction sites or vehicles. And the last source is, of course, open data, land registry, utilities, biodiversity, or mobility. And the last pillar of TWIN is services and features to improve the user experience and to optimize our projects, such as Colas carbon calculator, or we can also create a custom map and much more.
Well, fantastic. So let's come back to environmental issues. I was not the only one. I realized at coffee break I was fascinated by Sarah's presentation on the trees. And how does TWIN help tackle, for instance, urban heat islands, unknown soil conditions, circular economy goals, practical environmental issues?
Yes, indeed. TWIN enables to data import and export with urban heat island simulation tools, and we can visualize the results on TWIN. Secondly, we can have access to different sources of soil report from our past projects, but also we have the different information of the national subsurface database. And this enables us to de-risk studies regarding uncertain ground conditions. And the last thing, yes, economy circular. We can have access to route calculation and optimize it between, for example, our construction sites and the recycling facilities to support the circular economy approach.
Well, thank you very much, Maud. So it's fascinating to see in this session today how everything clicks together from the approach, problems-based, and then the technical pieces, and now the practical tools that we have on the ground at Bouygues Construction, at Colas. So what's in for the future? What's next for TWIN? Are there plans to integrate more deeply with AI and expand its scope, maybe?
Yes, indeed. The next step is to integrate artificial intelligence into Twin, first and foremost to enhance the user experience. As you know, AI assistants are now present in all the tools we use daily to send an email, to generate a meeting report, or to ask what you want to eat for lunch. So yes, AI will offer a new and more intuitive way to make queries on Twin. And secondly, thanks to AI, we will be able to querying to querying data from different sources, from BIM, GIS, or PDF.
Agentic AI, physical AI. Chris, maybe an idea for future sessions here. Maud, thank you very much for sharing your insights and giving us a hands-on look on how digital twins are making a difference at Colas, one of the Bouygues Group's companies. Joanne, I'll hand it back to you. Okay. And for myself, so I will go in the weekend in your treehouse. Okay. Thank you very much.
Okay, thank you. You know, I found that Chris is the most powerful person in this auditorium today. So we will have 3 spotlight speakers. At the end, we will have the Q&A session with all 3 speakers together. So please use Pigeonhole Live for your questions with the speaker name in front of your question. Okay? The first spotlight speaker is Gabriel Vincent. Gabriel is an Nvidia Omniverse and Digital Twin sales specialist. He supports companies in Southern Europe with their GPU virtualization, converged 3D pipeline, digital twins, and industrial metaverse project. Please join me welcoming Gabriel.
Hello, everyone. Super. Okay, so in 8 minutes, let's see how Omniverse, that has been presented by Jérôme, thank you, Jérôme, can be used to train physical AI-based robots. So we have experienced a lot of different wave of AI technologies. In 2012, with AlexNet and the CUDA development at Nvidia, the first perception model, the generative AI, the agentic, that are more specialized models to do some specific tasks. And the last one is physical AI. So what is physical AI? So we all know and enjoy the LLM models that are able to generate text, or images or video. A physical AI model basically gets instruction from prompts and generates token into action. So a physical AI model has an understanding of the physical world and is able to define and take action rather than text or images. At Nvidia, we have, so for those who enjoyed the show on Netflix, that is called the three-body problem. At Nvidia, we tried to define the three-computer solution. So to train AI, and we all know AI needs a reinforcement loop to get better all the time, we defined that first you need to train the foundational model at data center level. Those foundational models require a huge amount of GPU power to be trained. And then once you have this foundational model, you take it and you train it you put it into a virtual robot, into a virtual environment, so the robot can learn to walk, for instance. And then you take the fine-tuned model that has been trained in a virtual simulation, and you embed it into the physical embodiment of the robots. So when we come down to digital twin, industrial digital twins, and real use cases, so we created Omniverse to build those digital twins to aggregate data coming from multiple sources and ISVs to tackle many different challenges. And you see on the right side of the slides, the robots here is learning to walk. We believe that digital twins will be used for robots to learn to be robots. And this is a challenge where you need one of the challenges that needs to be addressed is the robotic data gap challenge, where you need to build and to have sufficient amount of data to train those robots. And synthetic data generation will help you to bridge this data gap. And you will use simulation, physically based, physically accurate simulation to generate those accurate missing data to train those physical AI robots. And this is all comes down to a fact here that everything that today is moving, everything that moves will be autonomous tomorrow, and everything that will be autonomous will need to be trained. And the speed and the quality of those training will be important to be relevant and to be competitive in this market. No one will train something into the real world anymore. It takes time, it costs money, and it is dangerous, and it causes a lot of safety issues. Everything that moves and that will be autonomous will be trained into simulation, also because it allows you to do it faster. If you have a digital twin, someone talks about the fact that digital twin helps you navigate in time. We believe that digital twins are also a time travel machine. And that you can factorize and accelerate how you teach physical AI. So how do you build a digital twin? First, you probably need to tackle different challenges. The infrastructure that is required is quite important. The incompatibility of tools, the fact that the data that needs to be aggregated most of the time are in silos and that are built by disconnected teams together. And it requires a lot of data preparation. It slows down the iteration process of creation. It generates a lot of problems that needs to be tackled. How do we tackle that? First, we are leveraging at NVIDIA with Omniverse. We are leveraging, and this is probably the most important component, the OpenUSD format. So, Jérôme, you mentioned it earlier. USD is Universal Scene Description. It is an open, standardized, open source object standardized way of describing virtual environments. If I were to explain it very quickly, this is basically the HTML for 3D. If the web has been so successful for the last 30 years, it's because we have this unified and open and interoperable way of describing web pages that can be interpreted by many different devices and browsers. We need the same for 3D environments, and this is OpenUSD. Like HTML, OpenUSD has been sanctuarized into a foundation. So this is the Alliance for OpenUSD. This is under the Linux Foundation. Everyone, every organization, every company can join the Alliance to orientate and collaborate, contribute into the roadmap of the future. Like the HTML, it evolves and it needs to stay retrocompatible. Like the HTML, if you try to, if you have like a machine, a 20 years old computer and you try to open Google web page today, you won't be really able to open it. But if you take 10 years old Google web page, you still will be able to open it with a new browser. OpenUSD will provide the same. The models, the twins, the different 3D assets that are created today will still be usable in 20 years' time. However, it will also evolve like the HTML has evolved over time. So this is the plumbing of the industrial digital twin, if I were to do an analogy. And then we have Omniverse, and Omniverse, what it is. Omniverse is a development platform to customize and develop physically based industrial applications that are leveraging OpenUSD. It is an API toolbox that is disaggregated and that helps ISVs to integrate specific technologies from NVIDIA to render, simulate, contribute and build and have those digital twin living in real time, and also to aggregate at scale a huge amount of heterogeneous data sets that are coming from many different ISVs, many different IoT system, AI models, pretty much everything that you want to aggregate can be aggregated through OpenUSD, and Omniverse is the top layer to take advantage of that. and I'm 15 minutes in advance. Thank you very much. 15 seconds.
Yeah. Thank you, Gabriel. You can leave your microphone here and also clicker. The second spotlight speaker is Frederic Vache. Frederic is the head of innovation at Dassault Systems. Please join me welcoming Frederic.
Good morning, everyone. So let's step back a little bit on talking about digital twins, from digital twin to virtual world. So first, it all came up, 40 years ago on paper and pen, right? Engineers were imagining and designing, engineering their parts with a pen. And at that time, people were digitalizing, starting to digitalize this process, making a drawing on a computer. But it was not at all the Dassault Systèmes DNA. The bet of the company was not to digitalize, but to virtualize. It means that if you need a drawing, you will generate the drawing from the 3D model. So the data model around all Dassault Systèmes history is key, because this is the way to represent the world. The world is not flat, it's not in 2D, it's a special world in 3D, and it has to start from that. From a part to a complex product, what we call digital mock-up. And everything you are doing in the virtual space can deliver value as you have the data model. You generate everything you need. The drawing, obviously, the renderings, the NC programming to program your NC machines, the robot programmings. So here it comes to the real automation and the real value. So when we talk about AI those days, the real trend is not AI, it exists for long, machine learning, deep learning, reinforcement, and so on. It's generative AI, because it really brings a real value out of your data. Obviously, from the product to the factory, and all factories are around the world mostly virtualized with our solutions, especially in aerospace. 100% of planes, drones flying around are digitalized with our solutions. It's 8 of 10 out of cars on the roads today. And the real big deal is to have the real virtual twin of the product, of the process, and on the factory, which is 100% conform with the reality. So we are a science-based company to do what you need to do in the virtual space, to define it, to optimize it, to simulate it before doing it in the real life. And then when you are doing it in the real life, like in this factory, monitor it to follow it, optimize, and execute. We started a lot of those virtual twins on the cloud around virtual plateaus. It started with the Falcon 7X, and here you have an example with the Boeing 787, because all the big industrial projects are not done by one player. They are all collaborative projects, and here you see with Boeing, there are 200 industrials around the world working collaboratively into a digital mock-up, which is obviously very secured. The IP of this project is very important, and orchestrated by Boeing. As we are hosted by Bouygues, I cannot resist to mention a project on building and constructions. I started in the 90s with Frank Gehry. I created a joint venture to virtualize building. Obviously, with Frank Gehry, it was complex buildings, so simulation were required. But as we've done the offer, and now Bouygues is a strong partner of Dassault Systèmes, the big thing is not only design and simulation, but it's collaboration on project management to run your project on plan or on schedule. Virtual twin, virtual factories, virtual universe, as now we are modelizing the complete territories on cities, are all your products are connected. It has been mentioned in the past. And since 10 years, we're investing a lot on virtualizing human. Virtualizing human from molecules to organs. Many examples. In the past, obviously, we're working a lot in medical devices, in prosthesis. But molecule designing at the nanoscales is very important. And this is where AI and Gen AI will play a strong role to help the pharmaceutical company to invent the next molecules. A few examples here. Living Art project, virtualization of the art, to not only design in 3D, which is just a visualization. This is not at all the value we are providing. It's the real physics which is behind in the virtual world. And from that, we can go over a lot of usages, like virtualizing arteries, to, with AI, provide the real match with the real stent that the surgeon will have to implant, and very soon produce the stent on demand. A project in India, we are reconstructing skull of patients in order to design prostheses, 3D print prostheses, and the surgeon will implant the real prostheses based on the form of the patient. For facial surgery, obviously, it's very important. It's already in production. An innovative project in France, Lattice Medical, we scan the breast of a patient in order to design in lattice design, generative lattice design, with 3D print with biomaterial, which is the same material than the sewing for skins, so that the surgeon will implant this prosthesis, the tissue will grow on this prosthesis, the prosthesis will disappear in the body, so the woman will recover her form. Another innovative project is this micro-robot, kind of pill you are swallowing in order to avoid a coloscopy. So in this pill, you will be able real-time to see inside the body of the patient in order to detect. Another project which is of interest, which is under clinical trial at Hartmann Radiotherapy Center, the biggest in Europe, in Neuilly. A virtual reality experience for the patient to live his radiotherapy treatment before the real one. It's very important because it's distressing the patient so that he's calmed down and the treatment is going well right the first time. So using virtual worlds for good. This is also an interesting project, mixing simulation. During COVID, we used a lot. We supported 150 projects, by the way, during COVID over our platforms. Sneeze simulation to understand the propagation of the virus, to help better protection, but also to help the hospitals to protect themselves and to see the propagation of those viruses inside a building. What we are building is 3D universes, which is the aggregation of all those virtual twins within an environment in order to deliver real usage, real value. So it's not just aggregating data from satellites, from sensors to monitor, but it's also to real-time have a way to assist the, in that case for territory management in case of fire, assist the best rescue plan. So we model all the rescue system on parameters so that our algorithm can provide the best route. Algorithm, by the way, which are used in most of the big logistic chains, like the ones you know when you buy and you receive your packet in front of your door. Those guys are our clients. So this is, in short, the history of Dassault Systems. I created 10 years ago the 3D Experience Lab to accelerate disruptive innovation that strongly impact the society in order to influence the metamorphosis of the industry. Metamorphosis of the industry is the next 20 years. We'll have to inspire the transformation for a better world. And this is what we do at the 3D Experience Lab. It's a collaborative project. Everyone is welcome to help building a better world. We are accelerating projects in life sciences, in energy, in mobility, small startups that think bold ideas, disruption, and we help them to go from an idea to product and industrialization. You can find in the App Store 3D Experience Lab. You can take all those projects with you in augmented reality or online in a virtual world because, as you know, Dassault System is bringing also 3D everywhere, not only for the industries. Thank you very much.